In this video, we're going to apply the logarithm properties that we've been working with, and we're going to use them to help us solve some equations that have logs in them. All right, so this slide here is just an introduction. I want to just kind of show you where we're going. All right, this kind of problem we've already worked with a whole bunch, right? We know how to solve this, right? We have log base 5 of x minus 3 equals 2. In order to solve that, we need to change that to exponential form, and that would be 5 squared equals x minus 3, and 5 squared is 25. So 25 equals x minus 3, and we'd just add 3 to both sides, and you get x equals 28, right? That, we've already done stuff like this, okay? So I just want to show you where we're going. We're going to basically do the same type of thing with things that look like this, right? Now, these problems we haven't done yet. That's what we're going to do in this video. But I want to first help you guys to understand that what's the difference? Well, the difference is that these kind of new problems that we're going to work with, they have 2 different logs, right? And then we might have more than that in the future, but these have 2 logarithms, right? Where we used to just do these equations with 1, right? But our goal is to get these type of problems to become like this type of problem, right? And what we're going to do is we're going to use our log properties, right? And we're going to have things like this, change it into things like this, and then just apply what we have been doing this whole time. All right, so that's our plan. Okay, so let's start with this one. Now, again, I've got 2 different logs here, right? I've got log base 6 of 3 plus log base 6 of x plus 4 equals 2. But let's think about our log properties. What do we know about the logarithm, or 2 logarithms that are added together? Right, well, we know that that can become 1 logarithm of the product, right? In other words, it would be log base 6 of 3 times x plus 4. Right? So when you add these, right, it becomes 1 logarithm of the product. Right? And I can simplify this as log base 6 of 3x plus 12. Right? And now, this problem should be easy, right? We can change this to exponential form. So this would become 6 squared equals 3x plus 12. And that's just 36 equals 3x plus 12. All right, and then we can finish this off pretty easy, right? I'm going to subtract 12 from both sides. So we have 24 equals 3x. And then if I divide both sides by 3, we get x is equal to 8. Okay, so there's our answer. But again, the key step was here in the beginning, using our log properties, and remembering what happens when you add 2 logs together. All right, I would like you to do this one. All right, so remember what happens when you add 2 logs together, and then go ahead and finish. Please pause and do it. All right, so here's what you should have done. When we add 2 logs together, that becomes a single log of the product of those 2. Right, and the product of these things, that's just going to be 3x plus 11 multiplied by 2. Right, and of course we can just rewrite that as log base 4 of 6x plus 22 equals 3. Right, and now we have 1 log, so now we can change it to exponential form. So it's going to be 4 cubed equals 6x plus 22. And we know 4 cubed is 64. And then we can keep on going from here. Let's see, let's subtract 22 from both sides. So that gives me 42, equals 6x. And then if I divide both sides by 6, we get x is equal to 7. Okay, and that right there is our answer. All right, I should also mention, right, if you kind of think back, why is this the answer? Why is this 7 here the answer? Well, that's the answer because if I were to plug that in, that would make these true. Right? If I plug that in, that would make that true. Let's look at another one. So this time, I've got a subtraction of 2 logs. Right? So let's think about what happens there. What does our log property say? Right? It says that if I subtract 2 logs, that's equivalent to this. The 1 log of the quotient of those parts, right? It's going to be log base 5 of 13x minus 14 over x minus 2 equals 2. Right, so we can turn that subtraction to log of that division problem. Okay, now we need to change this into exponential form. So this would be 5 squared is equal to all of this. All right, I know 5 squared is 25. And now to solve this, what I'm going to do is I'm going to multiply both sides by x minus 2 over 1. Or just x minus 2. So that gives me 25x minus 50 equals 13x minus 14, right? Because these factors here divide out. All right, so then now let's go ahead and keep going. Let's see, let's subtract 13x from both sides. And that's going to give me 12x minus 50 is equal to negative 14. And then if I add 50 to both sides, I get 12x equals 36. And lastly, if I divide by 12, I get x equals 3. Okay, and again, just as I mentioned on the previous side, why is this 3 the answer? Because that is the number that we're to make this true, okay, in the beginning. All right, you go ahead and do this next one, please. All right, please pause and do this one. All right, welcome back. Now you can check your work. If I have the log of two logs that are being subtracted, that becomes one log with our log property, log base 2 of this quotient, 2x plus 10 over x plus 2 equals 3. Okay, that's really the key, is changing this into one log using that log property. Now that I have this log equation, I can just change it to exponential form. So that would be 2 to the third power equals all of this. All right, 2 cubed is 8. So 8 is equal to 2x plus 10 over x plus 2. All right, and then to solve this, let's multiply both sides by x plus 2. All right, that gives me 8x plus 16 on the left, and then on the right, these will divide out. I get 2x plus 10. All right, let's subtract 2x from both sides. The rest should be pretty simple. We get 6x plus 16 is equal to 10. Let's make more room here. And then if I subtract 16 from both sides, I get 6x equals negative 6. And then if I divide both sides by 6, I get x is equal to negative 1. Okay, there's our answer. All right, we've got one last one. Okay, and this one's again the challenge one, right? So actually, I want to see if you can do this one on your own. Okay, and then at the very end, there is kind of one thing to be aware of. Okay, so go ahead and try to start this one on your own. We'll see what happens. All right, let's see how you did. Okay, so this time I'm adding 2 logs. And our log property says that if I add 2 logs, that's going to become a log of that multiplication problem. Right? X times x minus 4. And I know that I can simplify that to be x squared minus 4x. All right, so that part's not hard so far. Now let's change this to exponential form. So this would become 2 to the 5th power equals x squared minus 4x. 2 to the 5th power is 32. So 32 equals x squared minus 4x. All right, so what makes this a little bit different is that now I have a quadratic equation. Right, and you got to go back and remember, how do I solve a quadratic equation? Right, well, let's first subtract 32 from both sides. And then I'm going to have 0 equals x squared minus 4x minus 32. Right? And now this is an equation, a quadratic equation in standard form. This one can be factored. Okay, I'm not going to go through all the steps, but if you use your magic x, you'll get x minus 8 times x plus 4. Right? And then if I set those equal to 0, x minus 8 equals 0, x plus 4 equal to 0, we're going to get x is equal to positive 8 and x is equal to negative 4. Okay? Now, there's one little thing you got to be aware of here. Okay? It looks like we got two answers here. But actually, one of the answers doesn't work. Right? And to figure out which one, let's go back to the beginning. Right? So our beginning problem, let me kind of zoom out. And let's do a little bit of work over here. All right, our beginning problem was this: log base 2 of x plus log base 2 of x minus 4 equals 5. Right? And we said if these are solutions, they should make this true. All right, let's test them. And let's see what happens if x is 8. So if x were 8, I would have log base 2 of 8 plus log base 2 of 8 minus 4 equals 5. Let's see if this is true. Right? Log base 2 of 8, that's 3, plus, right here, 8 minus 4 is 2, so this is log base 2 of 8 minus 4 is 4. I'm jumping ahead of myself. And then log base 2 of 4, this is 2. So we have 3 plus 2 is 5. And yep, that's true. All right, so we know x equals 8, that works. So this one is a solution, right? And I'm claiming that the other one doesn't work. X equals negative 4 doesn't work. Let's double check that. Let's see if that does work, right? So if I were to plug in x equals negative 4, I would have log base 2 of negative 4 plus log base 2 of negative 4 minus 4 equals 5. And we get log base 2 of negative 4 plus log base 2 of negative 8. Right? And this is not true. Right? And the reason why this is not true is because you can't do this logarithm. Right? 2 to some power is negative 4. Well, that doesn't work. Right? You can't take the log with a positive base of a negative number. Right? That just doesn't work. Okay? So negative 4 is not a solution. The only solution is 8. So you have to be careful. You have to just double check your answers and make sure they make that true.